in the chat say, don't forget to record. So let's start this over. I'm now recording. Thank you so much, my code-panions. Yeah, I know, this post is total, whatever. Okay, welcome to Code Talk. I hope that the time we picked allowed people on the West Coast to be able to join us. Tonight we have a special guest. His name is Martin Snyder. You can see his face in a tiny box right now. He is recently left his former company Wingspan, which was acquired by IQVIA. He was the CTO there, and he had worked there for 17 years. So he had been there a while. He graciously, when I approached him and asked him to come on and give us his advice from all this experience that he has, he said, yeah, sure. So thank you so much, Martin, first and foremost, for coming on. I really appreciate it, and I'm sure everybody here does.
You're welcome. I'm glad to be here.
Before we get started, okay, it's recording. Just wanted to ask that everybody, it looks like everybody's muted. Just mute unless you have a question. I'll be monitoring the chat, so if you have any questions or you can't use your microphone for some reason, you can put it in there and I'll relay it and read the question out loud. And Martin's going to talk about his experience. He studied at Cornell University, so he went a different route than most of us as far as getting his programming knowledge. And he's going to talk a bit about his work experience. And since I kind of advertised this as a chat, we'll be able to ask him questions. But let's just give him a few minutes to go over kind of a spiel and get some stuff out before people start attacking him with questions, okay? If it gets a little too crazy, I might jump in and have us all just go to the chat. So we'll see how it goes. But thank you for being here, everybody. And lastly, I wanted to just say how Martin and I met. We met at a networking event last fall called Network Suburbs in the suburbs of Philly. And it's just I just decided to go and talk to people about what they're kind of looking for, just to practice. And we struck up a conversation, and Martin was talking about how Wingspan approaches technology and how their teams work, their development teams work there. And it was neat because I drew parallels to how the Flatiron online curriculum works, kind of the way it's structured. And so we talked a bit about that, and I got his info and just kind of kept bothering him. And so he graciously kept responding to my questions and emails, and we just kept in touch, and I've learned a lot from him, including last night. He gave an amazing presentation. After this, I will send out a link to his Twitter there's a video posted on it now. If anybody wants to check it out, there's a video about how to build a chat server on there. And it's really cool. If you want to learn, just get sort of an overview of a different language. Go on there, check it out. you put a lot of stuff out there. So it's just neat to go see the stuff you put out, Martin. So I guess that's it for my end. You want to go ahead and get started?
Sure. So one of the things that you said was that I learned how to program in a different path than everyone that's joining us today. First of all, thank you everyone for joining us today. I don't even know if that's exactly true. My educational path was definitely different. I learned to program mostly on my own. My first experience programming, this is back in the era where Commodore and Atari and Texas Instruments dominated the home computer market, and I had a Commodore VIC-20, and friends of mine in the neighborhood and we would get together and we would basically enter programs from magazines. They would print the basic source code, and we would just bang on the keyboard and get the thing working. And we were just, kids. We barely understood what we were doing, and that was kind of the start. And even at Cornell, when I was studying computer science, uh, I I found in my career I was not in a position to really apply computer science as a programmer until I was very well established. And all of my early success and experience was based on simply having done a lot of programming on my own. Um, and it's a really kind of um, a simple determination for who is and who isn't a programmer. Anyone that programs is a programmer, and the barriers now are really really low compared to what they were earlier, for doing even like professional level development. Like back then, there were the barriers were higher, and the barriers were higher even just for hobbyist type stuff. So. Um, Going all the way back, that's kind of the first step that I ever took. Just working with stuff that I barely understood, and I think that's even true today. Like a lot of people that are just getting started with programming, that first moment that you have an impact on something, you take something that already works and you make it build, and you make some change, and you see the manifestation of that change on the screen, and that's a really empowering feeling. And I think that the people that end up loving programming, a lot of them can remember the first time they were able to make something happen, whether it was um, you know uh, making some text blink on the screen, or like move back and forth, or whatever the first step was. A lot of people can have a really clear memory of that. And Yeah, changing Facebook's login page is another good one. Um, so so that was how it all started for me, and it really, that part of it never really ended. I'm just as curious now about learning new things about programming as I was then. I just have decades of accumulated knowledge from having learned a bunch of stuff, which I happen to still remember.
That's cool. That's cool to hear.
I think the other thing that I would say about education, since that was one of the early questions, is when I was going to college, computer science was really the only on-target major for people entering the computer field. They didn't have majors like software engineering. They didn't have majors like information systems or anything like that. And that presented a challenge for a lot of people, I think, because computer science is one of many disciplines that can cause people to be effective with technology. And you'd see, if you look around now, you'll see people with varied backgrounds, people with mathematics and econ degrees, people with music degrees, people really with degrees in almost anything, being very effective in the software field. And I think that was always the case, but back when I was doing it, it was the case for such a narrow minority that they were almost invisible. And today's world, there's a lot more people that are career changing. There's a lot more people that established credibility one way or another simply through their ability to program, and much less with their educational background. But of course, there's still certain parts of the country, there's certain companies that are looking for very specific degrees. But I think that shift has already started, and that's going to become less and less important as time moves on. One thing that hasn't changed is that when you're first entering any career, your resume is so narrow that really all you have is educational background on there. So that can be frustrating for people that are running up against that, is that you have very little else to talk about. So I mean, that's a challenge that I faced myself. When I was interviewing for my first jobs, is there's a lot more to somebody than their educational background. But if that's all you have on paper, then I guess that's all you're going to be talking about during your interviews.
Did you think, oh, sorry, we have a question come up. So what would you say you see us beginners need to focus on to make our possibilities increase in coming to find jobs and having credibility?
Okay, so that's a great question. I think there's a couple different angles you can take on it. What my personal message is that you can learn a lot about a company from their recruiting process. So for instance, if I was applying to a company and they made me go through some torturous system where I uploaded my resume and then field by field had to do data entry for all the information that was already in my resume, and then do a phone screen where it was though somebody had not looked at the database or my resume and I had to explain it all over again, I would personally find that to be a turnoff. But it isn't that simple. I think that people want to look for processes that are compatible with what they have to offer. And there's a lot of companies that are simply not well suited for entry level people, for programmers or necessarily for other disciplines. And that's something that I'm not sure if there's great resources on helping to identify companies that are better suited than others. But it's something that Wingspan in particular was strong at when I was there, and continues to be strong at. And part of what we did was we had a blind admission process. So we didn't even look at resumes. The only thing that we did was look at the results of a 60-minute written test that candidates took, where they would answer a word problem in the programming language of their choice. And what our goal was, that the purpose of our recruiting program was that we wanted to see the best in every candidate. We didn't want to evaluate people and screen based on resumes, because what good does it do you to interview the people that are the best at writing resumes? It seems like a silly thing that isn't really related to job performance. And so that was one thing of defocusing on the resume. And then the second was having some sort of merit-based assessment that could be used as screening, and do that in a way that you would get the person, you get their best behavior. So rather than bring them in and torture them in a small room with a whiteboard and a bright light, and find out how they perform under odd forms of pressure, programming in a manner in which they may never program before and probably will never program again until they interview the next time. Put them at their own computer, at their own home, using their own tools they're familiar with, and things like that, to create more of a real world scenario. And we were trying to signal a lot of things with that recruiting process. We weren't simply trying to evaluate candidates as effectively as possible and bring a lot of people in. We were also trying to signal that we were real people and we had a heart, and we were at least making as strong an effort as we could to fight bias and to lower the anxiety that's involved in the recruiting process. And so I think, getting back to the question was, what do beginners need to focus on to increase the possibility of finding jobs? I think that you want to look for organizations like that. You want to look for organizations like that are going to give you a fair shot and are going to want to work with you to evaluate you in a way that they can see exactly what you have to offer and what you can bring to the table. And that's going to be a more personal process. And the things that are the less personal processes, it's tough, right? It's going to be is tough if you feel your resume doesn't have the exact match of buzzwords that they're looking for. you're going to get filtered out. You're going to get filtered out by a machine, and it's not a human process, and that makes it very hard for people entering the field, regardless of which direction that they are coming in. The second angle to take, which isn't an area of expertise for me because I haven't really worked as a recruiter, and I haven't gone through a lot of personal job searches in my career. This Wingspan Technology was the fourth company that I worked for in a little over 20 years. And the one before that I founded, so I didn't have to interview there. So so that made things a little easier for me. But what a lot of people will tell you is that you want to leave as little to chance as possible. And by that, what they mean when they say that, especially in the recruiting standpoint, is you don't want to expose yourself to a dehumanizing screening process. That's you're rolling the dice, and you're rolling like a 20-sided die potentially. It's a very challenging area to penetrate. And so what you want to do is you want to come in through the side door. You want to have human eyes on your resume. You want to have somebody that will walk it over and get you a fair evaluation. You don't want to get clipped by a machine, is the simplest way to say it. And so if I was applying at a job, XYZ company, what I would do is I would Google. I would throw that company into LinkedIn, for instance, because I have a broad network on LinkedIn. I would throw the company name into LinkedIn, and I would see how close I can get to someone there. And it doesn't have to be someone that I know personally, because a lot of companies these days will have referral bonuses and stuff. So there's plenty of people that will be happy to advocate for a stranger for a shot at 500 or 1,000 or more dollars for basically doing nothing, just providing access. But often you can do better than that. Often you can find someone that will spend 5 or 10 minutes telling you about the company and getting to know you, and hopefully forming a positive impression where they can say, hey, let's give this person a shot. Let's bring them in for a slot, or I'd be happy to make these arrangements or something. There's really your worst case scenario is no worse than where you would be going through the front door. So the first thing is to look for companies that are more welcoming to people in your situation, is the first piece of guidance. And the second is to simply never come in the front door. But that second piece of advice people would tell you at every stage of your career, that you would never want to do that.
Nice.
So, okay, so now we'll go switch straight to the next question. Were there ever times you struggled or had doubts about being successful as a computer scientist? Did you face imposter syndrome? Let me think about that for a second. Not many, I would say. Part of that is, I have to thank my mother for this. My mother worked hard to get me exposed to computers at a young age. That big 20 I was talking about, I was 5 or 6 when we first got that. And I wasn't programming at 5 or 6, but I built a familiarity with computers and a comfort level at a stage where that was kind of a new thing for society as a whole. And so that was helpful. My greatest struggles, we'll go back to the first point. My greatest struggles were the highly theoretical aspects of the computer science curriculum at Cornell. It didn't have much to do with programming. And I struggled. It wasn't the kind of stuff that I wanted to do. I wouldn't consider myself at that point a great student. And I wasn't willing to do the work to do things that didn't come naturally to me, that I wasn't familiar with. And that's something that I feel I'm much stronger at now. But that was scary to wonder, am I going to be able to complete this curriculum? And what's the point if this stuff seems so far away from what I really want to do? And then the imposter syndrome, it's occasional, but not recent. I mean, I've spent so much time as presenting technologies, especially in leading organizations, that I've really gotten very comfortable with it. And I think imposter syndrome has a lot to do with that lack of comfort. So if you bully through it and you get through to the other side, things do get easier. And it's been a while for me since I felt that way. But that's not to say that there's not still small anxieties or things like that. But imposter syndrome, I think a lot of that has to do with questioning whether you belong, or questioning how you got there or something, or am I about to be exposed? And it's been a while for me since I did that. Let me see. There's more questions. Oh, looks like a question for Meg.
Now, he's asking how I described that there were parallels between Wingspan and Flatiron. I think we were talking about code reviews. And I was saying how the assessments were kind of like what you were describing when you guys would hire on a entry-level programmer and have kind of like a mentorship and review the code with them.
Right. So one of the things that we would do is we would have a pairing exercise as part of our interview process. And this is, if you ever get in a situation like that in an interview scenario, it can be intimidating, but a lot of the intimidation comes from not knowing how it's evaluated. And ours really wasn't different in that regard, because even if somebody tells you how it's evaluated, you can't necessarily trust what they're saying. I mean, there's a lot that, a lot of subtle things that would go on during a pairing exercise. But what we would look for, what we would honestly look for, is a bidirectional exchange of information. It's great if both people walk out of there having learned something. Doesn't have to be something hugely valuable or impactful to their life. Just, oh, I never saw that before, and how did you learn about that, and where did it come from? Those sorts of things. That's kind of essential to a pairing exercise. A lot of times, especially when people that are newer to the field get involved in a pairing exercise, you think of one person's like the leader and the other person's the learner in the pair. And some you can do it that way, but that doesn't really bring a lot of value. The real value in a pairing exercise is when both people are getting something out of it. So if you take even that example, if you had someone who was like the architect working with someone who was there on their first day, if the architect struggled to explain things clearly to such that the other person understood, well, then that might, the architect could walk away from that with a lot of additional thinking to do. Of, do we need better documentation? Have we started people too soon? Are we not evaluating for the right things in the recruiting process? Like everyone wants to always be, thinking about doing their best. And then at a more tactical level, when you think about when you write a program and then you run it, there's what you meant, and then there's what you typed, and then there's how the computer interpreted what you typed, which is three different things. And when you pair with someone, you get an extra person interpreting what you typed. And that person will provide feedback in a different way than your IDE or your text editor will, and it will provide feedback in a different way than what the computer will. And most people are not, fantastic at evaluating their own work. So one of the reasons that pairing is so effective is because of that feedback loop that gets created. Is that extra set of eyes is actually it's adding a 50% increase of the kind of the surface area of who's looking at things in real time, which is really valuable. And then you have the other feedback channel where people are saying, well, I would do it a different way. What do you think of this? And that leads to discussion. Discussion leads to clarity, and clarity in the field of software engineering really leads to success. I mean, that's where people do their best work, is when they have a clear vision. They're able to manifest that vision directly, and then they're able to get feedback on that result quickly. So pairing can help with all of those things.
Yeah, Martin, I remember now. It was in our study sessions, because you were telling me, I was asking you how you guys onboard new programmers, and you told me that, and I was saying that sounds a lot like the study sessions we have, because a lot of times we'll come across stuff where the instructors, something will come up and it's something an instructor doesn't exactly know how to answer, but they're just like, I'm not sure, let's Google it. And like, they're open to learning new things. Or a student will come to them and say, oh yeah, I found that's like, this works for this problem. And they're like, oh, I didn't know that, thanks for telling me. So it's cool to see how that exchange of information, and you telling me that happens in the workplace too. So yeah, that's really neat. Maceline asks, Um, oh, real quick, Brandon said, would you mind repeating what you said about discussion and clarity?
Right. So
Discussion.
people with the recording will be able to see how
Yeah.
I'm able to repeat this. I think what I said was that discussion leads to clarity. So you get a meeting of the minds early, and clarity is key in the field of software development, because what you want is you want to have a clear vision of what you're trying to achieve, and then you want to manifest that vision in code. And then you of course want to evaluate what you've written in terms of looking at it operating, to see what comes back. So where things get muddied is people don't understand the requirements, or people don't understand exactly how the APIs they're using work, or they don't understand the intricacies of the protocol. And so when you lack that clarity, that's how you end up with things like, I've written this HTTP client, and then it gets a 100 response, which a lot of people have never heard of, which means, hey, I'm still working, but continue to wait for the actual response, which is coming later. And then they get this unexpected response and everything breaks down, and it's because they had a lack of clarity of exactly what they were doing. And that's of course a very, very narrow circumstance. A lot of times the lack of clarity comes with what you're trying to achieve with the product, or what you're trying to achieve with a feature set or something like that. So having that discussion with people, not just other programmers, but a diverse body of people within the organization, and having not just an individual with clarity, but having a collective clarity, that will make everybody much more effective, much faster. And you can, of course, stumble through it, and you can go through multiple revisions, and you can have a high defect rate and issue patch releases and stuff, and you can reach the same result that way. But of course, that would take much, much longer. So it's better if you can achieve clarity. And then the tricky part is recognizing that, because on the one hand, you can very often define very clearly what you do know, and then the trick is understanding the parts that you don't know, or having that realization that you actually do know everything about this narrow section of the application. So establishing clarity and what that means is a little bit of a trick, but when you do have it, then that's when everyone's going to do their best work.
Thank you, Martin.
Yes, and it's now the question about should we work for a company before founding a company of our own? I would say absolutely, absolutely, for several reasons. The first is that software is harder than people realize, but it's also easier than people realize. And if you could bring a product all the way to market on your own without ever having worked for anyone else, that would be impressive. Not impossible, but impressive. But to go from that point to then scaling the organization, to be able to hire people and manage them and get the most out of them and fairly evaluate them and provide feedback, and get rid of people who aren't performing, and do all of these things without violating any laws, and figure out the right balance of raising money versus working directly versus delegating tasks to others. I think that's impossible. I can't imagine somebody getting that right the first time. And when you look at the examples that people might cite about others that have done that, there's almost always something to their story that people are leaving out when they like Bill Gates is a good example, where he was able to use family connections to bring in some really experienced managers very early in the process, and that was so. If that's on the table for you, I recommend doing that. But there's no substitute for experience. And I think the best way to articulate that is that good judgment comes from experience, and experience comes from bad judgment. And most people would rather learn from bad judgment at someone else's company rather than learning from bad judgment at your own. So it looks like the next question is, what kind of programming did I do? So let's see. So the dawn of time for me was BASIC. So that was I was never really excellent at BASIC, but I was able to do crude things with it. People of my era, a lot of them learned Pascal. I never really learned Pascal. I took one class in it. I went straight to C. So in the end of high school, I took a class in C. Which at the time was slowly becoming the dominant professional programming language at that point. That was kind of the start of the modern era. And so my first jobs In college, we studied, we did a little bit of C, a little bit of C++. We did some research languages like Scheme, which is a Lisp variant, Prolog, which is a rules engine. Scheme and Prolog are both functional programming languages. I can't remember any others there. Professionally, though, it was C++ on Windows for my first 3 jobs. So the first one was a company doing ERP integration software. So ERP is Enterprise Resource Planning, and that's like SAP is the dominant fixture in that. They were back then, they still are today. And so we built software that helped integrate SAP and other similar systems with the rest of the world. And this was also, it coincided with the dawn of the internet era, which led to a lot of more open integration packages like what we were building. The second company I worked for was also C++ on Windows, and that was a healthcare information system. What we were trying to do there was take clinical data coming from medical devices. So if you've ever been in a hospital, visiting someone, they have like the infusion pumps with the drugs, and people plug in a number of what the rate to feed the drug in, and the pump will do all the work for you. And then every 15 minutes, the blood pressure cuff will automatically inflate and take a measurement and chart it on the console and everything. We were looking at ways to take all that information and put it onto a network, an event bus, a publish subscribe event bus, and all of the data would then be aggregated on these dashboards, which would help you look at everything that was happening, for instance, in an ICU in real time, and do data analytics, not just on a per patient basis, but on the entirety of the unit. And the geography was built in there, so you could, for instance, potentially detect something like a minute raise in temperature of multiple people that were close to each other, which would indicate something like an airborne infection or something like that. The third company was the one I founded, and we made computer games. We made a real-time strategy game for Windows called Strife Shadow, which shipped in 2001. The website's still up. Game's kind of tough to use because the matchmaking service is no longer running. But the website for people that wanted to check it out is ethermoon.com, ethermoon.com. And also, like, the links for all this stuff that I might talk about are on my personal website. If you go to martinsnyder.net, you can find links to pretty much anything that I might talk about in this conversation. So then we get to the Wingspan era. Wingspan was building web applications almost from the start. On the back end, we were on the JVM for most of it. So we wrote code in Java, and then around 2010, a little after that, we adopted Scala. And so we had a mixed code base of Java and Scala running on the Java virtual machine. And then on the front end, we went through multiple iterations of JavaScript. We finally settled on ES6 JavaScript and TypeScript over a 17-year journey. And there was other things mixed in there over time. We had an ActiveX control written in Visual Basic, which we converted to C++ at one point. We had some SharePoint integration software, which was written in C#. And ultimately, where a lot of people arrive at when you accumulate enough experience is the individual languages will matter less and less, and the programming techniques that you use and API knowledge and things like network protocols and stuff will start to become more and more important. So I hope I answered that at the right level of detail. Let me see. Feedback regarding a first programming job being remote versus local. Okay, so my recommendation always for remote versus local is remote versus local is not an individual thing. If it is an individual thing and you're remote, you're going to have a little bit of a problem. There are organizations that are remote focused, and typically, everyone is remote, or almost everyone is remote. And then there's organizations that are centralized and also have some remote workers. And in those organizations, the remote workers, they have to work harder to be included in the conversations, and that can be frustrating. So if if your first opportunity is with a fully remote organization, I think it's not going to be an issue. But if your first opportunity is with a centralized organization, you should not be remote. The second thing I'd like to say about that is that my entire life, I've never learned more about anything than I've learned about programming from my peers being a programmer. You will learn more from your coworkers than you will from any other possible source of information. And this isn't just comparing your experience at Flatiron or some other program to that. It's really anything. Like I learned more in my first 6 months working at a company that it's changed names, but it was OneWave was what it was called when it went public. I learned more in my first 6 months there than I've learned at any other point in my life. And so I would highly recommend that you be really ingrained in whatever your first organization is, and you take advantage of all possible learning opportunities. Another thing, if you end up in a situation where you're remote, the best advice that I can give you is to work towards a culture of everyone treating everyone like they're remote. So that means less hallway conversations and more Slack, for instance, or making sure that every meeting invitation has call information on it, even if everyone's going to be in the conference room, or habits of recording all these meetings for people that may not be there, so the information can be captured and stuff. And so working towards changing some of the culture to be more supportive of people who may not be within the walls. So do I recommend one over the other? I don't. I think they're both fine. You want to be with the majority in your first organization. You don't want to be a minority player. So if the majority are remote, remote's fine. If the majority are local, then you probably want to be local. So this question from Sim, I don't fully understand.
What language?
Language.
Are the med devices using? Sim, can you unmute and ask the question?
You mentioned in your job that you were getting data from the medical devices. I was just curious, the actual device, what language is it programmed that you're able to get the data from it?
So this is a long time ago for me, but it wasn't a language that the devices were really talking in. What the devices were doing back then was they were dumping information through a serial interface. So and probably a lot of these still have them, because things like this in regulated industries and things in especially the type of equipment that's used in an ICU don't change with great frequency. So I wouldn't be surprised if a lot of them still have serial ports. So you would need to connect a serial interface to something and then build a repeater which would put it on the event bus. It actually wasn't something we spent a lot of time doing, because we were focused more on all of what the application could do with the data once it was there. So we were simulating a lot of the payloads for the time that I was there, because that pulling information from a serial interface was very well understood at that time. The language, though, was C. I mean, almost all those interfaces are very low level from that era. So C and C++ are interchangeable for that purpose. So what has been my biggest challenge as a programmer? That's a tough one. I'd say one of the hardest problems in programming is probably programmers evaluating other programmers. That's a real challenge that I think our field has not really gotten better at over time. Individually, there were some horrible things I remember having to work through that are less common now. When I was making the game, there were some real challenges in debugging DirectX applications, because you'd be in the situation where your program basically would have direct access to video hardware, and certain things could go wrong, which would be very inconvenient. Like for instance, if you set a breakpoint in certain code paths that would do DirectX, and it attempted to invoke the debugger while it was in the process of writing to the video card, that would just basically lock the entire machine, and that would change some of your work patterns. I guess a fun story from that era, there was one thing we were dealing with. So we were building a real-time strategy game, and the way that those work is they run basically a shared simulation. So every machine that's part of this peer-to-peer network runs the exact same simulation. And what you send from machine to machine are the individual commands. And a command would be something like, hey, take this unit and move it to this location, or attack this building, or tell this building to produce a new unit, or something like that. And so all these simulations will be running at the same time, and you would use the network to keep everything in sync, both in terms of time and in terms of messaging. So if one hadn't reported, all the other games would pause. And if you play games, I mean, like StarCraft was the one that we all loved back in that time. They all work the same way, where one person who's lagging will cause everyone's games to kind of lock up a little bit, and that's the effect that you're seeing. One of the problems we faced was that the simulation wasn't always reliable. And so, if you imagine someone's walking straight towards a tree, and Brandon definitely played StarCraft. You're walking straight towards a tree, and the direction you want to walk goes right through the middle of the tree, and it's floating point arithmetic, and you're either going to go left or right based on some very, very small rounding element. And what we would see is on some machines, the guy would go left, and on other machines, the guy would go right. And once that happens, the whole game is ruined, because it gets out of sync, and you can never recover from a synchronization problem. And what the problem was reduced to, I mean, this I think took I would say 4 to 6 weeks for me to both figure out and remedy. The problem is that the operations for floating point arithmetic are not associative or commutative because of the rounding elements of IEEE floating point notation. And so if you've studied this part of computer science, or if you've studied this in any other context, it's complicated, but it gets to the core mathematics of things. And so the ultimate culprit ended up being really minute implementation differences on Intel versus AMD hardware for what they call the MMX instruction set, the multimedia extension instructions. And what they would do to speed performance is they would take like some really big mathematical operation, like A plus B plus C plus D divided by E plus F. And they could produce like minutely different values, and that would screw us all up. And the answer ended up being to not use IEEE floating point numbers, and that was not fun, because you can swap that out for something else, and what you swap it out for is fixed point notation. These are all really fun things to Google if you've run out of things to learn. And then when you switch to fixed point notation, you think you have everything solved, except then you no longer have access to the entire mathematics library, so you have to like evaluate ways to handle trigonometry, square root functions, stuff like that. So you basically have to rewrite a lot of stuff which you weren't expecting to spend any time working on. So that was a big personal challenge. I don't know if that was the angle that we were shooting for with the question, but it was something that I spent a lot of time thinking about and working on. So I'll cut it short there, because I could probably talk about that one problem for an hour by itself.
Do you think you can do like answer it in like a more general sense rather than like a specific problem?
In a more general sense, the biggest challenge as a programmer, I would say the biggest challenge in a programmer is showing restraint. In a more general sense, is the nature of programmers to want to help people and to do well. And you can fall into a trap where you say yes too often, and you basically commit an entire organization to a path with very little thought or preparation. Someone says, wouldn't it be nice if the software did this? And you don't fully understand what this is, but you can do it just well enough to satisfy that one person, and then it ships. And then all the people that are experts say, well, now that you're doing this, what about these 10 other things? I'm going to log defects against what you've done because they don't handle these scenarios correctly. And you were just trying to be a nice person and help people, and now you've created a lot of work, and this work may not be strategic. And so I think fighting that impulse is probably the biggest challenge, not just for me, but for a lot of people. And what the answer is to be more disciplined in sticking to the plan. The answer is to have a better vision of product management. And if you don't have a product management team in your organization, get one. because you can't spend all the time building that level of awareness at the same time that you have your hands deep in the code. The two disciplines require completely different fields of vision, and it's very, very hard to do both at the same time. So I think that would be my general answer to the question.
Awesome. That's a really good answer. Thank you. So our chat's going up, so let me scroll up. Brandon asked, what's it like being a CTO, and what was your day-to-day?
So the day-to-day varies. Being a CTO, there's a couple different elements to it. I think the most important job of a CTO is you need to decide which problems your technical organization is going to solve. And what I mean by that is you have to decide what you're going to work on versus what you're not going to work on versus what you're going to outsource to a third party. You have to decide what you're going to write versus which libraries you're going to adopt. You have to decide which technical challenges you're going to take on. You have to have I mentioned field of vision before. You have to have a very broad field of vision to make the decisions at that level. It's not enough to just be a smart guy and always be able to fix the bug and be able to write code quickly or something, because you can write code very quickly that takes you in a direction where you're going to be writing a large volume of code which isn't strategic to the organization, and that's really what the danger is. So you need to be focused on what problems the organization is going to solve. That's one. Two is as a day-to-day responsibility, you have to be aware of what other organizations are doing. It's very important that the CTO know what practices are out there, what libraries, what techniques are out there that you're not doing, because it's very easy when you put the blinders on to think that what you're doing is the best way, and you can fall behind really quickly, and that can hurt you in many ways. It can hurt you because you're inefficient doing something that other people are not having a nearly as hard a time with. It could hurt you because you fall behind from a recruiting standpoint, that certain parts of the market look at your job posting and they say, oh, well, these guys are stuck in the dark ages. They haven't modernized. It's not the kind of place I want to be. And they might otherwise be happy there. And if you could get them in the door and talk to them, they might actually really want to be part of your organization. But that screening process works the same way. It's just like I said, the resume screening can hurt the candidate. The job posting, you can screen people out by having a job posting that sends the wrong signals out to people. Sometimes you're looking at code. Sometimes someone needs help to figure something out, and a lot of times the CTO, especially in a smaller organization, wrote a lot of code at some point. You need to be able to diagnose things when things aren't behaving correctly. You have to have a clear vision of what the fully operating machine looks like, not just the software that your organization has written, but the libraries that you use and the operating systems and the operational infrastructure. You have to understand how all that stuff works and what it looks like when any one of them are not working correctly. So if something is going sideways, somebody needs to make a fair assessment of where to look if the frontline staff hasn't figured it out already. So a lot of times, life isn't always as simple as getting a call stack, which the first half of the call stack is stuff that you're working in and you're familiar with, and the second half is code you wrote. Sometimes there's no call stack at all. It's just, hey, these messages are getting dropped, or hey, this thread vaporized with no warning or notice, and I don't know what to do next. So it's tricky. And then there's people. I mean, a big part of the CTO's job is communication. You got to communicate up, down, and sideways. And what that means is you got to communicate to your team so everyone's on the same page and knows what's expected of them. You got to communicate to whatever leadership exists above you, whether it be a CEO or a board, and sideways, your other leaders of your level, whether they be department heads or part of an executive team. Part of your job is to make them understand what you're doing as much as they need to, and to understand what they need so that you can you can take that into account in the decisions that you make. And that's just with the internal elements. And there's a huge communication responsibility externally. And externally could be, for a lot of CTOs, would just be clients. But for certain organizations, a CTO has to be if you're pushing, for instance, development tools, you got to be out there speaking at conferences. So it's more It's more of an audience than just, direct, clients in small meetings. If you're with a public organization, then you're going to be talking to shareholders one way or another, or analysts or other parts of the financial markets. If your company has, private equity or VC or some investment community involved, you have to be explaining to them, what you're doing and why you need so much money. So there's a lot that goes into it, but so the communication is definitely a big part of it. There's more to it than that, but I think a lot of it ends up being, specific roles for specific people in specific organizations. But I think that's a fair starting point to understand the role. So let me see where we are.
So just a brief pause. It's 8:52, and so we had this session scheduled till 9, and we've got like 3, 4 questions left. So I'm not sure if you want to just pick one to answer, Martin.
Well, let's take a look. So let me see. Languages matter less. I'm looking for knowing protocols. How do you learn all this, and where are good places? Okay, so I'll answer the question here that what I said before. Languages matter less, and what's going on around those languages matters more. And how do you learn this, and what are good places to learn and everything. And the best kind of soundbite I can give everyone for that is that continuing education in the field of technology is a personal responsibility. If you look at other fields like an engineering field or legal, accounting, medical, continuing education is built into someone's primary job duties. They have to recertify every year. They'll be sent for training to learn the latest codes and standards, and then they'll be tested on that, and they'll recertify, and they'll be good for another 12 to 24 months or something. There's no such thing in technology. There's some organizations that will invest in training people and helping them learn things they don't already know. But it's usually not enough. So the people that are going to be successful make a personal commitment to learning. They have a natural curiosity, and ultimately you can't stop them from continuing to ask questions and just go deeper in the stack. And it's just a question of which direction that they go into. I'm going to stop going into as much detail, but that's kind of what I would say for that. So here we're learning Ruby on Rails and React at Flatiron. However, there are lots of opportunities that are very similar in nature where the skills we are learning will transition very nicely. How can we apply for jobs using different stacks and languages that we are learning to still be competitive? This is a trick. Some of it's organizational. Some organizations are going to do what I would call skill-based recruiting. A lot of times you can tell they'll say something like, "Oh, we want someone who knows the Spring, a Spring programmer with 5 years experience." You could be some, really agile savant who is very, fast learner and everything, but you won't get far enough through the process. So looking for organizations that don't do skill-based recruiting is probably the key there, or just to have like a prove it moment. Like I was in one interview where someone said, this ended up being the second company I worked at. They said, "Well, what do you know about design patterns in C++?" And I said, "Well, I've never heard that term before." And they said, "Well, we only hire people that know design patterns, and you should read this book." And so he told me what the name of the book was. I bought the book. I read the book. And it turned out I knew a bunch of that stuff. I just hadn't heard the term and didn't know the vocabulary. And so we talked a week later, and I ended up getting that job. So I demonstrated that I was able to learn on my own, rather than have the company have to take a risk. So just think of it from the employer perspective and what you can do to de-risk them. So if you think you can move from Ruby on Rails to, like, for instance, TypeScript quickly, just go do it, right? Do it and prove it to them in some way that you hope will be acceptable. Okay, that's less of a question. How many years does it typically take to become a mid or senior level engineer? It seems that the market is more so desiring that level of expertise rather than junior level. How could one overcome the challenges in regard to getting hired as a junior developer? This is a great question. So the reason people don't like junior developers is that they are expensive to train. And if you don't train them well, they're not going to be worth very much. And if you do train them well, they're going to be worth a lot more. And not all organizations are ready to handle that growth. And so they end up in this really negative pattern where the people they are successful with leave for potentially a lot more money. So a lot of it's organization dependent. So that's why you want to look for companies that do hire entry-level people. And if you're interviewing there, you should ask, how long they stick around. Because it's okay if they only stick around for 2 or 3 years. It's just, you want people to have a shared expectation, right? Having a shared expectation, having goal alignment between an employee and an organization, that leads to happiness on both sides. You don't want to go in thinking I'm going to be here for 10 years and be an architect if that's not practical. I think it takes most people between 3 and 5 years to reach what I would call peak coding ability, of professional development. Around that time, and in the beginning, you're learning so much, and especially when you're just starting your career, you're learning so much about so many things. It's incredibly exciting. Every 6 months, you're twice as good, 5 times as good. It's amazing how quickly people develop, and eventually that tapers off. And I think it's about the 3 to 5 year mark, and you can get a lot better after that. But you probably won't be a lot better at tactical programming unless you learn whole new languages which introduce you to new styles. So for instance, if all I did was Java programming in those 3 to 5 years, I'll probably become about the best Java programmer I'm going to become. But if I then go learn a completely different language that is not similar to Java in any way, that would make me a better programmer by having a diversified knowledge of things like that. It also depends, like a lot of times in certain organizations, your knowledge of exactly what that organization does, that makes you valuable and leads you to a higher level. Your ability to communicate and educate other people can make you a senior engineer. The kind of acute measure that I like is what's the biggest program you can keep in your head. You'll find that a lot of people you can imagine a 10-line program and people will recall that easily. 100 lines, probably 1,000, less likely, 10,000, 100,000, million. But there are people out there that just know almost the whole thing of some huge system, and that leads to seniority faster. And so having a good memory, instant recall of intricate details like that's really helpful in addition to the programming. So there's a lot of different reasons why career trajectories will go at different rates, and those are just some of them. So, do you jump in or do you trust your staff when something is going sideways? And the CTO is up to you. What solution you execute, do you always have to explain? So do I jump in? No, you trust your staff. And is it up to me? What solution? No. Ultimately, the people closest to the problem are going to have the most information. And so when I was a practicing CTO, when I had my hands in the code, when I knew a lot of stuff, then it would be appropriate to do that. But the further you get away from the day-to-day coding, you wouldn't want someone making a decision today based on knowledge from a year or two ago. You got to trust the people that are there, but you also have to listen to what they're saying, because a lot of times, people are saying like, don't do anything. We gotta take a breath and we have to study or something. And people that are too decisive can end up limiting what the total option space is. So you have to listen to your people, but you definitely have to trust them. The other thing, when you look at scaling an organization, the only way you can scale an organization is to give up some amount of control. And so you absolutely want to trust people. You want them to be worthy of your trust, and you want to put things in their hands. Because if you don't give away all of your current job responsibilities, you won't be able to then take on new responsibilities. That will limit your own growth. It will also limit your own level of engagement, because I think people are most engaged when they have a steady flow of new experiences coming to them. And so the only way you're going to get new experiences is to divest responsibilities, not to accumulate them. So that's my personal style. There's a lot of people that feel the same way, but it's not universal. I think those are all. Those are all the questions for me. I don't know if Natasha's question was for the audience or other people.
Cool.
1 minute over.
Yeah. I just had one question I wanted to ask at the end. Get mine in. What's one thing that you really wish you could go back and tell yourself? Okay,
so that thing that I said about continuing education being a personal responsibility, if I had known that earlier in my career, like for instance, when I was in college or when I was in high school, or more, if I had a more focus on that in my first 5 or 10 years. Like I learned a lot in my first 5 or 10 years, but I learned a lot in the context of exactly what the companies I was working for were doing. And now my perspective is much more about, personal research exactly in the areas that I'm not working on professionally to kind of grow and expand there. And I wish that I had figured that out sooner.
Okay, thank you. Thank you for that. All right, awesome. Thank you, Martin, so much for, again, giving us all this really valuable information. My fingers were flying. I took a bunch of notes, and we have the video, thank goodness. So for everybody who is on right now, we have a Slack channel called Code Talk. I'll share the notes on there, and once the video is up online, I'll share the video out there as well. And Martin, I'll share his contact information as well as part of the notes. Oh, and he said he's going to stay on for a little longer. So I think that's all there is. If there's anything you want to say real quick, Martin? Or...
No, thanks everyone for the questions. Thanks for showing up to hear what I had to say, and good luck to all of you as you learn and grow and enter the field.
Awesome.